object, 2 objects, 3 objects, 4 objects. That makes $20.
So just to review, now that we're recording, $20 is 1/20th of 200.
No, not the fraction. I caught myself at the beginning. I might as well just keep going with it.
Okay. All right. So last time we were doing this problem with the truck and the crate on the back. We're trying to find what minimum stopping distance is required to stop from 20 meters per second with the crate to not slide.
Not slide at all?
Not slide at all. So what am I going to do first? I've drawn a cute little picture. Now what?
Force diagram.
Force diagram. What real forces are acting on the crate?
Normal, mg, gravity, and friction.
Good. Normal, mg, and friction is to the left. Per the discussion last time, when this truck stops, the crate wants to continue moving to the right, and so the only way it's going to not move to the right is if friction pushes to the left and opposes that motion. So there's your force diagram. So now what? Oh, we had already done that? F net x, F net y equals n minus mg, and there's no acceleration in the y direction, so n equals mg. So that's that in review. F net x equals fric. There is acceleration in that direction, and its magnitude is 8x, and so the net force is max. And friction is mu normal. And we reminded ourselves that the equation for fric is less than or equal to mu normal, that when it's static friction, it's a smart force, and so it can be less than or equal to the static mu times the normal. But then when it's kinetic, when it's actually sliding, we know that it's equal to the kinetic mu times normal. Now, oh, okay, yeah, because we said right was positive, so this is negative F if right is positive. Okay? Now over here, this business right here is important or helpful to keep in mind that when it's kinetic, I don't have to worry about the inequality. When it's static, I do, but since I'm talking about a minimum stopping distance, I'm talking about an extreme, right? So that's when fric does equal. So I could write the inequality over here, or I could just keep in the back of my mind, I know that we're talking about an extreme, and so I can call it equals and know that anything longer than that would also be okay. Okay? So, now we're to a point where we can start rearranging and substituting, because what I really want to know is the maximum acceleration that's allowed, right? So the maximum acceleration is going to be negative mu over normal, which, what is normal? Well, from the F net y statement, it's mg over m. Well, hey, look at that. What happens? Yeah, the masses cancel.
So it's just negative mu times gravity.
Good, gravitational acceleration. So that, now I can substitute, that's negative 0.7 times 10. So what's the maximum acceleration? No, it's not negative 10 because it's just the magnitude of the acceleration, because the direction's in the y direction and we're dealing with x. Oh. Great, thank you.
So what was the minimum stopping distance? You just then have to find the change of x,
We don't have time, so what do you want to do instead of that? Anybody have any other suggestions if we don't have time?
VS squared equals 0, velocity is, oh wait, VS final is 0, and then initial is 180 plus 2 negative 7, no.
I like that.
Would you agree?
Shouldn't it be -7?
Thank you. So that when I move that to the other side, I get 14 delta x's equals 20 squared. So delta x, therefore, is 400 divided by 14.
28.6.
So I need 29 meters to safely stop.
Okay, this makes a whole lot more sense than last year.
Good. You got smarter. Or the work got easier. Hey, so let's work another similar problem then. I have a 20 kilogram block that's sliding across a frictionless surface at 7 meters per second. It's then going to hit a rough surface where the kinetic mu is 0.4. I want to know how long will it take to stop?
Once it hits
Times 2. I want both interpretations of how long. What are the two possible interpretations for the question how long? Time or distance? No. Alright. So let's solve this. You guys all nailed this. Alright. We know that first we're going to do the force diagram. It's going to look...
Oh, I get it now. Oh, God.
Alright.
Thanks for the first second. We were trying. We were saying yes. It started with that one.
So up to this point, it's exactly like the previous problem. F net in the x direction is fric. It's max equals fric, which in this case is, or you can do negative again, is negative mu mg. The m's cancel, and so acceleration is negative mu g. So the acceleration is negative 4 meters per second squared. And then it just becomes a matter of which one do you want to do first, delta x or time? X, please. All right. So then I'm going to, since I don't have time yet, I'm going to do final squared equals initial squared plus 2ax, where the final is 0, the initial is 7, plus 2 times negative 4x. Therefore, 8x is 49. Therefore, x is, what was it, 6.125. Sure, why not? And then the time, then, there's a couple of different ways we can find the time. What did you choose?
Trying to do this quadratic. Then solve the formula above it. It's really simple.
Yeah. Yeah, quadratic is the hardest way to do time, I would say.
That's what I changed to.
Yeah, you can use acceleration is change in velocity over time. So therefore, time is change in velocity over acceleration, which is negative 7, because final is 0 minus initial 7 divided by negative 4. And that's just 1 3/4 seconds.
Yeah, 2.
Then did you round or you got flat 2?
You're off by
I did quadratic and got 2.
Okay, that's fine.
Maybe.
Yeah, I mean, I'd have to see your work, but it's possible that it was okay. Alright, so that's all well and good. But what if we do this?
So you found great kittens.
Yes. They're tucked in tightly. Starts at rest. Let's make it spikes. The kinetic mu for the crate and the incline. And by the way, keep in mind that mu, the coefficient of friction, is always for two surfaces, right? I can't talk about the kinetic mu of the box because it depends on what the box is sliding against, right? So it's the kinetic mu for the two surfaces, which in this case is the box and the incline.
So it's basically an interaction between the two at terms of...
Point 1? Okay, sure, we'll do point 1. And the static mu is point 2, we'll call it. We'll keep it relatively simple. If the incline, the angle of inclination is 30 degrees. Again, we'll keep it simple. If the distance to the certain doom is 7.3 meters.
So the distance.
I know, it's wonderful, isn't it? No, it would be morbid if they were puppies.
No, we have it there.
Yes. Yes, I'm going to title this lecture, I love PETA. Alright. Yes, and then my house will get bombed. Alright, anyways. So it's a bit of a complicated question, right? I mean, in the sense that, first of all, I have to know what? First question I have to know is, are the kittens safe? What would be some conditions under which the kittens would be safe?
If there's no force on the crate.
Okay, almost, not quite.
If the normal force is enough to keep it set.
Good. If the normal force on this incline produces a frictional force that is enough to keep it set. Right? If the answer to that is yes, then of course that trivializes the second question. So then, part 2, if the kittens are not safe, then part 2 would be how long
Until they're due.
Okay? So again, if the answer to question 1 is yes, then question 2 is infinite, right? But if the answer to question 1 is no, then we can answer question 2. All right? So, let's see what we have here. What do I want to do first?
Force diagram.
You bet. Draw a force diagram.
Are the questions on the AP exam going to be as ridiculous as this as far as content? Not
Oh,
like
no,
actual
no.
math. I mean, like scientific.
They're politically correct. But,
What do you think?
You think so, Alex? Really?
It's
Is that a question, bro?
It's a pretty iffy question.
Is that an honest question? You're just messing.
Look at the book, some person jumped off the cliff.
Yeah.
But it was for fun.
Just
Just for fun.
Maybe Alex made it clear.
Yeah, and that's the book. All right. No, unfortunately, the questions on the test are much more predictable and boring. All right. So mg is on the crate. What else? Friction and normal are in which direction?
Okay.
Good. Normal is, by definition, perpendicular to the incline. And friction, by definition, is perpendicular to normal
Yes.
and up the incline, opposing the motion down the incline. Okay? Now, here's where I need to introduce to you one of the most important rules you'll learn all year. And that is how to set the coordinate system. Number 1 rule for setting your coordinate system is if there's acceleration, make it along an axis. If there's an acceleration, make it along an axis. Yes, thank you for the dramatic. Make it along an axis.
Oh.
In other words, line up an axis to where the acceleration is on an axis. Otherwise, you're going to have x and y components of your acceleration, which is doable, but it makes it a lot more complicated. Yes?
So does that mean we're going to have gravity that's off 30 degrees for mg?
Exactly. We're going to define the coordinate system to help us. So gravity won't be down. It'll still be towards the center of the Earth, but if down is negative y, we're going to change that. All right? Because it's going to simplify things. Because is there a preferred frame of reference? Preferred as in this one's right and follows the laws of physics, and that one is wrong and doesn't. Right. Okay, well, the term we use is preferred. There's no preferred frame of reference, right? They all work equally. So we get to pick the one that we want, all right? The second rule is if there's no acceleration, then choose a coordinate system with the most forces along the axes. So rule number 1, the most important one, is if there's acceleration, make it along an axis. If there isn't an acceleration, then you want to choose axes so that as many as possible of your forces are along axes. AX, yes. Yep. Spelled the same. Now, rule 1. Choose a coordinate system such that the acceleration, if there is one, is along an axis. Do we have acceleration? Maybe. We don't know yet, right?
It would be along the
Whether we do or not is the answer to question 1. So we've got two choices. We can assume we do, or we can move to rule 2. Let's do both. Let's assume we do. If we do have acceleration, where will it be?
along that slope.
Along the incline, down the incline, right? And so that would make the coordinate system look like this. This is x, that's y.
Everything we know about math was put on the side.
Not really.
What about 2 plus 2?
That equals
We broke that.
plus 1.
We beat that last year, right? 2 plus 2 doesn't always equal 4, does it?
Wait, what?
Really?
What?
2 plus 4 doesn't always equal 4.
2 plus 2 will be equal to
No, it
2
doesn't.
plus 4 equals 6.
2 plus 2
Oh yeah, that's what you're talking about.
does not equal 4,
2 times squared.
right?
But you have to qualify the
Vectors, right? With vectors, 2 plus 2 doesn't equal 4, necessarily. Alright.
If I see like a vector with like 1 plus 1, I'm just gonna write yellow for the answer. Give me some credit.
Okay.
Plus 1 equals yellow.
Yes, I did. Yes, I did. Alright. So let's go ahead and practice the second rule while we're here. If there is no acceleration, then how would we align the coordinates? Yeah, the same way. Because I've got the 2 perpendicular forces along the axes. So now I have 2 out of the 3 forces along axes. And that's helpful to me because now, with this coordinate system, how many do I have that has 2 different components, perpendicular components? Just one, just mg. So I'm going to take mg and I'm going to break it down into its components. I'm going to say it's got a component along the negative y axis, and it also has a component that is along the positive x axis. Right? So now it's time for everybody's favorite game. Find that angle. This 30-degree angle is where in this picture?
On
Well, I could redraw it here, right? Because it's what we normally call horizontal and how the x-axis intersects that. So then where is it in the picture? This is something that some students struggle with, so it just takes practice.
up in the corner by the
Let's,
on the inside.
where? Is it there or here? Here, I'll get the highlighter. Is it there or here?
There.
It's there. Now let me show you the geometry in slow motion. Here's a triangle. Right?
Yeah.
If that's true, then what's this angle? 60 degrees. And then x and y are perpendicular. And so if that's 60, then what must this be? 30. Okay? Now the shortcut is, if you do the coordinate system this way, the deflection of the gravitational force will be equal to the angle of inclination. But here's the long version, right? You can always go back and do this to find it. Okay? So now we can go back to this, these green and orange components and resolve them. What is this orange component? We could, but we're not because we don't need to. You got it. mg sine 30. Okay, slow motion. This angle's 30, therefore, the pink one.
Yeah.
Therefore, sine of 30 degrees equals the opposite, which is what we can call x, over the hypotenuse, which is mg. Therefore, x is mg times sine 30 degrees. Similarly, we can do the green, and it's mg cos 30 degrees. If we called it y, right, you can just call it whatever we want, but if we called it y, again, slow motion, y opposite, or excuse me, cosine of theta, or 30 in this case, is adjacent over hypotenuse. Therefore, y equals mg cosine theta. Okay? Now, well, we got to know the forces from our force diagram, because what are we going to do after we draw a force diagram? F-net statement. So let's do F-net of y first, since we just did y. If up and right are positive, which is a customary, but we'll label it just to be safe, then my F-net in the y direction is what? Good. N minus mg cosine theta, which in this case is 30 degrees. Now, even if there was acceleration down the ramp, what's the acceleration in the y direction? Good. Acceleration in the y direction is 0, so F-net in the y direction is 0.
Wait, acceleration in the y direction? Oh, because that's like going, that would be like flying.
That would coming off the ramp, yeah, off the incline, or going down through it. Therefore, N equals mg cos 30. Sine. Okay.
Whoa.
Okay, keep going.
All right. So sure. While we're here, what?
Negative 259.20. So ours is 59.
So we'll call it 260.
Because mg is 10.
Because m is 30, g is 10, and cos 30 is what, 8.87 or whatever it is,
M is 30, G is 10.
and then cos 30. Now, normally I wouldn't encourage you to substitute this early, but we'll allow it. Okay? You know what? No, I'm not going to allow it. Don't substitute yet. Keep it ng, cos 30.
You want to find N? Is that one of the things you're looking for?
Hold on. All right. So now let's do F net x.
Equals F friction.
Good. mg sine theta, which is 30, minus fric. Now, if there's no acceleration, then F must be what? Equal to mg sine theta. If acceleration in the x direction is 0, then fric is equal to mg sine theta. Well, what is fric? Yes, fric is mu normal, which is mu mg cos 30 degrees. And so I'm asking, is that equal to mg sine 30? Or not necessarily equal to, but greater than or equal to, right? Because if friction's larger than mg sine 30, it's still not moving, right? Because again, it's a smart force. Good. You tell me. We want to know if they're not moving, so it's the static mu. Okay? Now, why did I not want you... Yeah. mg's cancel on both sides. And I'm asking, hey, is static mu greater than or equal to tan 30 degrees? Right, I divided both sides by cos 30. And what is tan 30? Okay. So is our static mu was 0.2. So how does 0.2 compare?
It is about half.
Yes.
And the kittens die.
It is not equal, not greater than or equal to. And so are the kittens safe?
No.
No.
And it seems like they're going to die very quickly.
All right. Now, we sure did a lot of work. Luckily, we can save some of that work to answer the second question. We can keep all this from our FNet statements. Well, you can just keep it where it is. I'm just moving it for clarity's sake. Get rid of my 2 plus 2 equals. Okay? So, how far did I say? 7 meters? 7.3 meters. So this is 7.3 meters. Alright? So acceleration is not equal 0. So what does acceleration equal then? ma in the x direction, mg sine 30 minus mu kinetic, because it's moving, normal, mg cos 30 degrees. Alright, try and finish that up for next time.